Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the quotient rule for derivatives. So determine dy over dx at the given value of x. So the first function is y equals x squared minus 25 over x squared plus 25, and we have to find the dy over dx at x equals 2. Now this function is a rational function, so we should use quotient rule to find its derivative. So the first step is, so we'll use the Leibniz notation. So dy over dx. And now as per the quotient rule, we'll start with the derivative of the numerator, so which is 2x minus 0. So 25 is a constant, so that's why its derivative is 0, times the denominator, which is x squared plus 25, minus the numerator expression, x squared minus 25, times the derivative of the denominator, which will be 2x plus 0, over the square of the denominator. Now we have to find the value of the dy over dx at x equals 2. So we should sub in x equals 2 in this expression. We do not have to simplify it first and then sub in the value, because that will save you some steps and time. So in the next step, we can just sub in x is 2. So we get, so 2 times 2. Now since subtraction by 0 doesn't change anything, the 0 goes away. And in the next parentheses, we get 2 squared plus 25 minus, and then we do 2 squared minus 25. And then in the last parentheses, the 0 goes away. So it's just 2 times 2 over, and in the denominator, we do 2 squared plus 25 and then square. Now we can simplify the numerator. So dy over dx. So 2 times 2 is 4. So we get 4 parentheses 2 squared is 4. 4 plus 25 is 29. Minus, now 2 squared is 4 and 4 minus 25 is negative 21, times, and 2 times 2 is 4, over, now in the denominator 2 squared is 4 and 4 plus 25 is 29 squared. Now we can simplify it further. So dy over dx equals, so in the first part we'll do 4 times 29, which is 116. Now in the second part we have to do minus negative 21 times 4, so it will become positive. So we'll get 84, because there are two negative signs, so they combine to become a positive sign. And in the denominator we do 29 squared, which is equal to 841. Now we can simplify this expression too. So dy over dx equals, so we do 116 plus 84, which is 200. So we get 200 over 841. So this should be the final answer for the derivative of this function at x equals 2. Now we can analyze the second given function. Now in this function, the numerator is made up of two expressions in the parentheses that are being multiplied, and it's the same in the denominator. So in order to use the quotient rule, it's easier to first distribute the terms in the parentheses in the numerator and denominator. So for that, we can use FOIL method. So we'll distribute the x in the other parentheses, and then we'll distribute the 1. And we'll do the same thing in the denominator, so x times x, then x times -2, then -1 times x, and then -1 times -2. So first we rewrite the expression after distributing the terms. So in the numerator, we get x squared plus 2x plus 1x plus 2 over x squared minus 2x minus 1x and then plus 2. Now we can combine like terms. So we get x squared plus 3x plus 2 over x squared minus 3x plus 2. Now we can, sorry, not 4, sorry, 2. Now we have to use the quotient rule. So the expression will be, dy over dx, we have to use the Leibniz notation. So dy over dx will be equal to, so we'll start with the derivative of the numerator expression. So the derivative of the numerator will be the 2x plus 3 plus 0 times the denominator, which will be x squared minus 3x plus 2 minus the numerator expression x squared plus 3x plus 2 times the derivative of the denominator, which is 2x minus 3 plus 0 over the square of the denominator. So x squared minus 3x plus 2 and then square. Now we can sub in x as 4 in this expression to find the value of dy over dx at x equals 4. So in the first parentheses we get 2 times 4 plus 3, and we can ignore the 0, and then 4 squared minus 3 times 4 plus 2, then the second part minus, then 4 squared plus 3 times 4 plus 2, and then 2 times 4 minus 3. So we can ignore the 0 over. So we get 4 squared minus 3 times 4 plus 2, and then close the parentheses and then square. So this is the expression we get after subbing in x as 4. Now we have to simplify this expression, so we can continue here. So we get dy over dx equals, so we'll start with the first parentheses. So 2 times 4 is 8 and 8 plus 3 is 11, and times, now 4 square is 16, so we get 16 minus 3 times 4, which is 12, plus 2. Now minus, now we'll get in the second parentheses, so we get 4 square is 16 plus 12 plus 2, and then times, so 2 times 4 is 8 and 8 minus 3 is 5 over. Now in the denominator, so 4 square is 16, so 16 minus 12 plus 2 and then square. So now we can simplify it further. So dy over dx equals, so in the numerator we get 11 times, so 16 minus 12 is 4, 4 plus 2 is 6, minus, and then in the other part, so 16 plus 12 is 28, and 28 plus 2 is 30 times 5 over, and in the denominator we get 16 minus 12, which is 4, and 4 plus 6 is 4 plus 2 is 6, and 6 square, which is equal to 36. Now we can simplify it further. So dy over dx equals, so now in the numerator we do 11 times 6, which is 66, minus, now we do 30 times 5, which is 150 over 36. Now 66 minus 150 is equal to negative 84. And this fraction can be reduced to just negative 7 over 3. So this should be the final answer for the value of dy over dx for this function at x equals 4. So these are the steps you have to keep in mind to solve a problem like this one. So you have to be very careful with the derivative. So you have to be careful that you don't make any mistake in terms of the distributing the terms and copying the sign of the terms. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.